Hello everybody. Today we are presenting this project called Retrieval Augmented Generation for question answering tasks. The objective is that we want to learn the various parameters in order to improve our Retrieval Augmented Generation for question answering. Some of the challenges addressed is, one is the original problem of Retrieval Augmented Generation, which is to obtain data that is not stored within the parameters of the large language models. The second and the third problems are those particularly addressed in our project. The first is to use an LLM to generate the data set, which is the question answering pairs, and to use another LLM to evaluate the question and answers generated. So we will try to optimize our RAG system by varying three parameters. One is chunk size, embedding type, and by performing re-ranking of the retrieved documents. Some related work that have been done is, first is the original RAG model done by Lewis et al. The second is the RAG benchmarking, from which we have taken many inspirations in order to benchmark and evaluate our own RAG project. The last is the QA evaluation, which is also very informative and has been helpful in our prompting of our LLMs to evaluate our LLM performance. The dataset we use is a set of 6 books related to wealth, wisdom, enlightenment. These are the names of the 6 books listed here. What we have done is we have taken these books in PDF form, extracted all of the text, and put it into a CSV individually for each book. The CSV will contain not only the text but also the source, that is the book number as given here. The methodology, we have pre-processing, wherein we split the documents into smaller chunks, ensuring semantic relevance. So this is one part of our project. The chunking size will be varied in order to see the impact of the chunk size on the retrieval augmented generation. One is the retrieval, where we employ a retriever to fetch the most relevant documents from knowledge base. We might also add a re-ranking into this to improve the performance of the QA. Third is the reading, where we have applied one LLM in order to answer the questions generated by another LLM. And evaluation, we have yet a third language model, which we will use to evaluate the answers by the second LLM. So in total, we have 3 language models that we have employed. One language model will be employed to generate the original question answer pairs and to filter them. Another language model will be to generate the answers on those question answer pairs that were previously generated by the other language model. And the final language model, which is GPT-4, will evaluate the answers given by the second language model based on faithfulness. Alright, that is all from my side. Next, Vaibhav will explain the rest of the code.
Thank you, Teiboklang. Here we start from our coding steps. First we did is question answering generation using Mistral AI. Then we filter question based on 3 different scores, that is groundness score, relevance score, and standard score. So groundness score, what is groundness score? It refers to the extent to which the generated answer from the Mistral AI and it compared with the different materials provided by retrieving documents. So it's basically comparing 2 question answers so that and that answer is considered well grounded if it directly refer to that given document. Second one is relevance score, and there's a name given. It measures how closely the generated content from the retrieved document and third one is standalone, which is that a question is as given the slide. This is a question understandable, free of any text for someone with domain knowledge or internet access. And okay, the next one is LLM read. So this is a retrieve document. We use a Zephyr for a reader LLM, and for retrieving document we use different embeddings. We also did the re-ranking. We use different chunking sizes like 100, 200, 300, 400, 500. For 500, and we also use the different embedding models for experimental setup, so that we get the optimal solution. We use embedding models like all mini LLM, Zephyr, and Roberta. We use GPT-4 for evaluating purpose, depending on faithfulness and overall system performance. Okay, so my next part is experimental setup. So what we did is we first we select a model. We use different LLMs and embeddings which are used to generate answer based on previously generated questions using mixed AI, of course. Models like Zephyr Beta and various embeddings from Hugging Face are tested. As I told you, we use different chunking size variations like 100, 200, 300, 400, 500 to get the optimal size for accurate information and retrieval pre-processing. Then for question answer generation and filtering purpose, we use mixed AI, and for quality control purposes, we use the filtering process where they are evaluated on groundness, relevance, and standalone score. We calculated the mean, median, and standard deviation of the scores with different inventory types. We also give the best optimal, most optimal supportive design for our RAG model. We also give the 10 different 10 different setups. Okay, the next part is result. Okay, this part is followed by my fellow mate Neeraj. Okay, Neeraj.
I am presenting the results of our experiment. We are dividing the data in the chunk size. We are dividing the data in 100, 200, 300, 400, and 500 chunk size, and we calculate the mean, median, and standard deviation of for different chunk size. Just like 100 chunk size, I have this one mean, median, and standard deviation. 200 have this one median, and different standard deviation. The mean and median score for a language model faithfulness are highest when the text size is 200. This suggested that the text size of a 200 provides a good balance between the context length and computational efficiency. Therefore, we could further explore text size around this size as we may obtain a better result. The text size increased beyond the 200. We found that the mean and median is a decline. This due to the larger chunk introducing the noise and irrelative context. We can observe that the standard deviation increases as the chunk size is growing. Larger chunk size may be capable to score a diverse content, resulting in a greater variability in its score. Second, we are embedding. We are calculating the three methods, three open AI methods. That's like mini LM, low, BERT, base, and GT small. We got all these three. We got the mean, median, and standard deviation from mini LM, robot, base, and GT small. GT small demonstrates the superior performance compared to mini LLM and robot. However, it also has the highest standard deviation, indicating the great variability in performances for different on test. When re-ranking we are another method to explore this one is the ranking. They have a true, false, and a true. False have a mean, median, and standard deviation. True have a mean, median, and standard deviation. When we re-ranking the set to true, the mean score increasing from 0.651677 to 0.69667. indicating the potential improvement in our overall performance. However, the median score decreasing from 0.700 to 0.675, suggesting that while re-ranking may enhance the mean score, it could also introduce more variability and in individual scores. This variability is reflected in the standard deviation (STD), which is significantly lower when re-ranking is true. The value is 0.038381 compared to when it is false. False value is 0.103711. The lower standard deviation indicates less variability in the score when the re-ranking is applied, highlighting the trade-off between the potential higher mean score and increasing variability of the result. Next, we are calculating the F statistics and p-value. Actually, we are implementing one-way ANOVA test for our data in 3 different parameters: check size, embedding, and re-ranking. F statistics is a standard mean deviation, a square mean in a group divided by a square mean within a group, and p-value is the probability of the data present in our context. The p-value, f-value and p-value from the result one-way ANOVA test for 3 different parameters: chunk size, embedding, and re-ranking. We can draw several conclusions. The parameter that extract the most significant impact on the output of the embedding type. This inference is supported by low p-value. The p-value for embedding is 0.00013, but from in our test, the p-value is lesser than 0.05. If p-value is lesser than 0.05, actually associated the embedding parameter, indicating that it's a likely significant. The outcome of the F statistics, which measure the variability between the group mean relative to the variability within a group, so the highest value for the embedding parameter 12.6289, further confirming its impact, while the re-ranking parameter, the highest p-value 0.20094, suggesting it may not be the significant in affecting the outcomes compared to the embedding. It still has a higher impact than chunk size. Overall, the result of one-way ANOVA test indicating that the choice of embedding is aesthetically significant, while the choosing of the chunk size and re-ranking is aesthetically significant. Third one is we are plotting the bar graph for chunk size and score, chunk size and embedding, and chunk size and score, embedding and score, and ranking and score. We find that in chunk size 300, the variance is more as compared to other, and this dotted part is defined as a point is outlier. It is not in this region.
Alright, so I will end this presentation by talking about the limitations and finally the conclusion. The limitations in this project of ours is there is increased complexity due to usage of 3 different language models. There is dependency on prompt quality. Whatever question evaluation we are doing, whatever question filtering we are doing, even the answering of the language model, it's all done based on prompts. So if the prompt quality is not up to the mark, then the quality of the RAG model will also be not up to the mark. Scalability and resource intensity. when we made this project for generating 100 questions, we found that for just 100 questions to complete this evaluation, it took around 2.5 hours based on the free collab resources. So if we want to scale it, obviously the computation power and memory required will be increasing in multiples. Another is that all the language models that we use here are all commercial, whether it's OpenAI or Hugging Face or Mixtral. They're all commercial AI language models. So if we want to improve our models, then obviously the commercial companies will not allow us to tinker with their models. That will cause some difficulties in improving our models. In conclusion, we have come to a few insights. One is that RAG boosts the question answering ability of language models. One is that we have found some methods of optimizing the components in the RAG system, optimizations in chunk size, embeddings, and also optimizations whether we can use re-ranking or not. Another is the dataset importance. Obviously here we have used dataset based on some PDF content, and if we can get a better dataset that is not PDF but purely text form, or purely we can extract it as from HTML, that would perhaps have a better performance. Some statistical insights we found from here as laid down by Neeraj. I will not repeat them. And finally, for future research, we can further explore on the chunk size, as we have seen that in the box plot around the chunk size of 300, there was a huge variance in the outputs. Embeddings, we only applied 3 types of embeddings. We could explore more types of embedding, and re-ranking also, we have only one algorithm for re-ranking. That can also be explored. That comes to the end of our presentation. Thank you.